welcome to the deep dive. Today, we're really getting into a major speech by Nvidia CEO Jensen Huang.
That's right.
We've got the full transcript from the Reuters live stream, which you, our listeners, shared. So our plan is to dig in, pull out the key takeaways, maybe find some surprises about where computing is headed.
Yeah, and the first thing that really jumps out, I think, is how Huang frames NVIDIA itself.
Right. Not just chips.
No, not at all. He's positioning them as, like, essential infrastructure. Think electricity, think the internet. That's the level he's aiming for.
Wow. Okay. That's a bold statement.
It really is, and it kind of sets the stage for everything else he talked about. It's not just marketing speak either, I don't think. If they actually pull this off, their influence becomes enormous.
Like a utility provider almost.
Exactly, affecting cloud costs, internet services, everything. And, well, it also brings up questions about monopolies, regulation, stuff we've seen before with essential infrastructure.
Definitely something to watch.
Yeah.
Okay, so let's unpack this whole infrastructure angle. He talked about this incredible evolution, right?
Yeah, from a, what was it, $300 million chip industry in '93.
Yeah, tiny compared to now. Then the trillion-dollar data center boom.
And now he's talking AI factories, AI infrastructure, measured in trillions, plural.
The scale is just, it's hard to get your head around.
Yeah.
Feels like a fundamental shift in the economics of computing.
It absolutely is. And the thread connecting all this, he argues, isn't just faster processors. It's this mix of accelerated computing, AI itself, and, really importantly, their CUDX library.
Some of the software.
The software, exactly. He made a point that they're kind of unique in how consistently they've focused on these libraries. CUDA isn't just a driver, it's this whole architecture for using the GPU for general tasks.
And the X libraries.
They build on top of CUDA. Highly optimized toolkits for specific jobs, deep learning, simulations, you name it. That tight hardware-software integration is their secret sauce, really.
He showed that demo, didn't he? The GeForce RTX 5060, real-time graphics.
Uh-huh. And the AI part was fascinating. DLSS neural rendering. It apparently only computes like 1 in every 10 pixels directly.
Okay, wait. 1 in 10. How does the picture still look good? Is it guessing the rest?
Sort of, yeah. It uses a deep neural network that's been trained on tons of high-res images. It intelligently upscales the lower-res render and basically predicts the missing details.
So it's not just stretching pixels.
No. The AI is generating detail based on its training. The benefit is much faster frame rates, smoother graphics, usually without much visual difference. Sometimes it even looks sharper.
Which brings us back to the software, those CUDA libraries being crucial. It's not just general-purpose speed anymore.
Exactly right. General purpose is fine, but for the heavy-lifting AI graphics, you need to deeply optimize that small bit of code that hogs all the processing time. That's where the specialized libraries come in.
He listed a ton of them. It was like a catalog.
It really was.
Chi for numerics, Aerial for 5G, 6G signal processing.
Right, processing radio signals faster for your phone, potentially.
Right, Parabricks for genomics, MONAI for medical imaging, Earth-2 for weather.
They're systematically building out the software foundation for basically every compute-heavy domain.
It feels very methodical.
And there's that positive feedback loop he mentioned. More GPUs with CUDA means more developers making libraries.
Which makes the platform better, attracting more users.
Which sells more GPUs. It's a cycle, a very profitable one, presumably.
He also touched on some really future-facing stuff. Aerial for AI in telecom is interesting.
Definitely.
But then CUD, quantum classical computing. He even predicted all future supercomputers will have quantum accelerators.
That is a bold call. I mean, full-scale universal quantum computers are still a ways off, right?
That's the general consensus, yeah.
But integrating quantum accelerators with classical supercomputers, that's happening now. Quantum is good for specific problems, classical for others. CUD quantum is the bridge, letting developers program these hybrid systems. GPUs handle stuff like error correction, pre- and post-processing.
So it's about combining strengths.
Pretty much. Most agree that's the direction, even if the exact timeline is fuzzy.
And speaking of telecom, he mentioned that 6-year effort on the radio access network stack, the RAN stack.
Yeah, getting their accelerated platform to perform on par with specialized ASICs. That's a big deal in telecom.
Moving into hardware territory with software, essentially.
Right. A software-defined RAN running on their platform means more flexibility, allows injecting AI right into the 5G, 6G network edge, dynamic optimization, new services.
And big names are partnering. SoftBank, T-Mobile, Vodafone.
Nokia, Samsung. Yeah, it shows the industry sees the potential there.
Okay. Then the focus shifted to AI itself, its evolution.
From perception recognizing things to generation creating things like text and images. That's been the last 5 years or so.
But the next leap, he says, is reasoning AI.
Yeah, moving beyond just making stuff to actually thinking through problems, understanding context, making inferences. That's the key step towards more general intelligence.
He mentioned chain of thought, tree of thought.
Right. Techniques for AI models to break down problems, explore solutions. It's about reasoning, which then enables the next stage, agentic AI.
The digital robots.
That's the idea, combining perception and reasoning so AI can understand, think, and act. He used that analogy of a digital HR managing digital workers.
And then building on that, physical AI.
Crucial. For agents to work in the real world, robotics, self-driving cars, they need to understand physics. Inertia, friction, how objects behave.
So it's not just digital tasks.
Exactly. They need that physical grounding. The example of AI generating synthetic videos to train self-driving cars in weird scenarios, that's physical AI in action.
Okay, so all this context, it leads into the Blackwell revolution.
Right, the Grace Blackwell system, specifically designed for scaling inference, the AI thinking part. And he stressed how hard scaling up is, bumping against semiconductor physics limits.
Moore's law, slowing down, that kind of
Pretty
thing.
much. You can't just rely on shrinking transistors forever. You need architectural innovation, which is what Blackwell represents.
And these Blackwell systems, they're already out.
Yeah, the HGX-based ones have been in production since late last year. Available now via cloud providers like CoreWeave.
But there's already an upgrade coming, GB300.
Immediately, yeah. Slated for Q3. Same footprint, same power, but upgraded chips. 1.5 times the inference performance, 1.5 times the HBM memory.
HBM being that really fast memory.
High bandwidth memory, yeah.
Yeah.
Crucial for AI.
And double the networking bandwidth. Big system performance jump overall.
The performance numbers were wild. A single GB300 node matching the 2018 Sierra supercomputer.
Which had 18,000 GPUs. It's a 4,000x increase in 6 years. Just staggering.
And then NVLink, the super fast switch.
World's fastest, he claimed. 7.2 terabytes per second. Connecting 72 GPUs with 130 terabytes per second of total bandwidth within a rack.
More than peak internet traffic, he said.
Yeah, it allows all GPUs in the rack to talk to each other basically instantly. It lets them disaggregate the GPUs, make them function like one giant motherboard inside the rack. Liquid cooling required, of course, at 120 kilowatts per rack. So these aren't just data centers anymore, they're AI factories.
That's the term. CoreWeave, Oracle Cloud, that XAI Colossus factory. Examples of this new scale. We're talking massive investments, like $60–80 billion for a 1 gigawatt factory, with most of that being the compute hardware.
But it seems they're not just building these factories themselves. He talked about NVLink fusion, opening things up.
Yeah, that was interesting. It signals a shift. They started by positioning themselves as infrastructure. Now, with Fusion, they're enabling others to build custom AI infrastructure on their tech.
Solidifying that essential infrastructure role.
Exactly. Moving beyond just selling semi-custom chips to enabling whole semi-custom systems, you can mix Nvidia GPUs and CPUs with custom ASICs or other accelerators, all tied together with NVLink for scale-up.
Scale-up being the hard part.
Right, and they're even offering NVLink as chiplet IP.
Meaning other companies can build it directly into their own custom chips.
Precisely. It lets other designers leverage that high-speed connection. He also mentioned supporting custom CPUs using an NVLink chip-to-chip interface.
So integrating their GPUs into systems built around, say, ARM chips or others.
Looks like it. They listed partners already: Elchip, Astera, Marvell, MediaTek for ASICs, Fujitsu, Qualcomm for CPUs. It's about making their interconnect tech more widely available.
Which could lead to a lot more specialized AI hardware built by different companies, but still relying on NVIDIA's core tech and software.
That seems to be the strategy, a broader ecosystem, but with NVIDIA at the center.
Then he announced a couple of actual products aimed at maybe making this tech more accessible: DGX Spark and Station.
Right. DGX Spark, the personal AI supercomputer for developers, researchers. A petaflop, 128 gigs of memory.
Which he compared to the big DGX1 from 2016.
Yeah, having that kind of power right next to you and always on AI cloud for prototyping, that's compelling.
Could researchers use that for complex simulations? Like in biology or material science, right on their desk?
Absolutely, that's the idea. Empowering individuals in smaller teams, accelerating early-stage work without needing massive cloud clusters immediately. It could democratize access, speed things up.
And the DGX Station, desk side, runs off a wall socket.
Yeah, the most performance you can get from standard power, he claimed. Enough to run a trillion parameter model, apparently.
A trillion. on a desk-side machine.
That's the claim. It's geared towards these modern AI-native applications, not necessarily for running your old x86 software, but for serious AI development. Both Spark and Station seem aimed at lowering the barrier to entry for cutting-edge AI work.
Okay, shifting gears slightly. Enterprise IT. He sees AI completely reinventing it, right? Compute, storage, networking.
Yeah, a fundamental overhaul. And agentic AI is central to that vision, too. Digital marketing managers, digital researchers, digital chip designers.
Digital workers filling gaps, boosting productivity.
That's the pitch. He mentioned Nvidia's own engineers are using them already.
And they announced hardware for this, the RTX Pro Enterprise and Omniverse server.
Right. A server designed to run the old stuff by 86, hypervisors, whatever, but also add these enterprise AI agent capabilities, text agents, graphics agents, and powered by a new CX8 switched network motherboard for super fast GPU communication within the server.
Performance focus seemed different too, not just raw speed, but throughput and latency.
Exactly. Tokens per second for overall throughput, but also tokens per second per user for responsiveness. That's the challenge for AI factories in the enterprise. He showed RTX Pro getting big gains over Hopper, especially with optimized models like DeepSeek R1, like 4x faster.
And storage needed an overhaul too, for all the unstructured data AI uses.
The Nvidia AI data platform, with a new query system called AIQ, the big idea is moving from CPU-centric storage to GPU-accelerated storage.
Because GPUs are better at churning through that kind of data.
Much better. He claimed 15x faster retrieval and 50% better query results. That's significant.
And they're offering blueprints, working with storage vendors.
Yeah, Fast, Dell, Hitachi, IBM, NetApp, trying to build an industry standard around this GPU-centric data approach. The example of Vast building a sales AI agent in 3 days using the blueprint was meant to show how fast this could enable enterprise solutions.
And finally, for enterprise, AI Ops, a software layer for managing models.
Right. Curation, fine-tuning, evaluation, security, the whole life cycle. Lots of partners listed there, too. It's about making AI manageable and robust for businesses.
It really sounds like they see AI becoming totally embedded in how companies operate.
Absolutely. Not just a side project, but fundamental.
Okay, the last big topic, robotics. Linked directly back to agentic AI.
Yeah. And the key enabler he stressed was simulation. Realistic virtual worlds for robots to learn in.
That Newton physics engine they developed of Google, DeepMind, and Disney.
Exactly. GPU-accelerated, high-fidelity, real-time physics. And crucially, differentiable, which helps with AI training.
Yeah.
They open-sourced it, integrated it into Mujoko and Isaac Sim, their robotics platform.
So Isaac is their end-to-end platform for robots, like they have for self-driving cars.
Same idea. AI model creation, simulation, deployment. They announced the Jetson Thor processor for robots, the Isaac OS, and open-sourced the Isaac Groot robotics platform, providing the hardware and software tools.
The really interesting bit, I thought, was the AI-amplified human demonstration.
Yeah, that tackles a huge bottleneck in robotics collecting enough training data.
So a human shows the robot something once.
And AI generates tons of variations, synthetic trajectories, based on that one demo. The Group Dreams Blueprint, he called it. It lets robots learn more skills with way less human effort. A small team can do the work of thousands, potentially.
And the big prediction, humanoid robotics is the next multi-trillion-dollar industry.
Because they're versatile, they can fit into our world easily. But it needs massive compute for the learning, the simulation, the deployment, and robots need to work together, especially in factories.
Which ties into Omniverse and digital twins again.
Right. Creating digital replicas of robots, equipment, entire factories. He mentioned TSMC, Foxconn. Others are already building digital twins.
For optimizing layouts, planning robot integration.
Simulating everything first. Testing, training, optimizing in the virtual world before touching the physical one. Saves time, money, reduces risk. Even cities are starting to use digital twins.
And just at the end, a bit of a surprise announcement, a new Nvidia Taiwan office.
Nvidia Constellation, yeah, in Taipei. He even asked listeners there to contact the mayor to support it.
Which really highlights their connection to Taiwan, the semiconductor hub.
Underscores those strategic ties, definitely.
So wrapping this all up, it's this vision of a totally new industrial landscape. AI factories, intelligent agents everywhere, digital and physical, and this robotics revolution.
It really is, and it's all interconnected. AI transforming graphics, now transforming enterprise, now robotics. It makes you, the listener, really think about how this wave is going to impact your own industry, your own work.
It feels massive, like the start of something truly transformative. Thanks for diving deep into this with us today.